Although they probably don't regard themselves as such, these men are conservationists, directly involved in a project of intense ecological significance. This construction crew, workmen, engineers, and divers, has been brought together to help one of the world's most beautiful places stay that way. This is Hawaii, and the project on which these men are at work concerns itself with restoring and preserving the quality of the ocean adjacent to the state's capital city, Honolulu. Nature and circumstance have conspired to make Hawaii a place whose beauty can meet the challenge of any other region on Earth. But there's no guarantee that she'll stay that way forever. Much of what makes living here so desirable is involved with the sea that surrounds our islands. The meaning of Oahu's name, the gathering place, has come to contain a greater and greater irony over the years as Honolulu and its suburbs have acquired more and more of the unavoidable complexities of a growing center of population. In 1970, the total population of Oahu, including civilian, military, and visitor, was about 650,000. 70% of this population was concentrated in the leeward, or basically Honolulu area. These figures are expected to more than double by the year 2020.
The old sailors named that Diamond Head because they discovered what they thought were diamonds up there, but it turned out...
The tour guide tells the visitors about Diamond Head, about Waikiki, Pearl Harbor, and the Blue Pacific. But he doesn't tell them everything, and perhaps it's just as well. He wouldn't want to spoil their trip with reminders of some of the unpleasant realities of life in any population center, even one as ideal as Honolulu. The old Outfall, in use until '76, discharged 60 million gallons of untreated sewage each day into the ocean, approximately 3/4 of a mile from shore and at a depth of less than 40 feet. There isn't a city on Earth without a waste disposal problem. It's an unavoidable byproduct of the human presence. But there exist many possibilities for dealing with it, all the way from doing nothing at all on the one hand to coping with it intelligently and progressively on the other. The city and county of Honolulu elected the latter course. The first major undertaking was construction of the Sand Island Ocean Outfall pipeline. The Honolulu Public Works Department engineers designed the new outfall to achieve a more efficient marine disposal of the city's sanitary wastes. The construction was jointly financed by the city, state, and federal governments. The construction contractor was the Morrison-Knudsen Company of Boise, Idaho. The construction management control system employed a critical path method, or CPM technique, for scheduling and measuring work progression during construction. The particular application for the Sand Island job was originally specified and then monitored throughout the project by the city's inspection consultant. The use of CPM was a valuable aid in accomplishing the work on time and within the budget established. The new outfall design called for nearly 14,000 feet of pipeline to be placed from the site of the sewage treatment plant on Sand Island to a point over 2 miles offshore at a water depth of 240 feet. To protect it from surf and storm wave action, more than half of the offshore pipeline is buried in a trench running to an ocean depth of 100 feet. Beyond the trench, the pipeline continues to descend to the 200-foot depth where the diffuser section begins. The diffuser section descends further to a 240-foot depth, then follows this contour to the end of the pipeline. Total diffuser length is 3,500 feet. Whereas almost all the effluent from the old outfall ends up floating on the surface, it's expected that the effluent from the new outfall will be effectively dispersed well below. The new pipeline is designed to handle a maximum load of more than 100 million gallons of treated sewage per day. This capacity will satisfy Honolulu sewage disposal until at least the year 2020. The total outfall pipeline consists of more than 600 pieces of reinforced concrete pipe, each 24 feet long. Each pipe section has 2 cages of welded steel rods up to 5/8 of an inch in diameter. The concrete forms are removed after approximately 20 hours of steam curing. 7 days drying time are required before one of these pipes has gained its full design strength. The 84-inch pipes weigh 33 tons each. Hard and semi-consolidated materials made extensive blasting necessary over most of the offshore trench line. 25-pound bulldoze charges spaced at 4 feet were placed on the surface of the coral formation. Many areas required multiple blast excavate cycles before reaching final trench grade, approximately 14 feet below the ocean floor. The entire offshore trench was excavated to grade before pipe laying began. The nature and magnitude of the seas generated by wind and waves required a pipe laying technique which would isolate the pipe from surface motion during joint assembly. A unique device constructed by the contractor specially for this project satisfied this requirement. It is the pipe laying horse. The horse is a 40-foot by 40-foot steel structure supported on 4 hydraulically actuated legs. Each leg can be retracted or extended independently. 29 hoses bundled together into a single umbilical run from the control console on deck to the horse. Whenever any manipulation of the pipe takes place, it's accomplished by the hydraulics operator topside under instructions from the diver on the bottom. The horse's clamps are carefully positioned over the pipe by operating the same controls that will be used to position and align the pipe during joint assembly. Hydraulic rams in the center and at each end of the pipe traveler provide fore and aft and side-to-side motion. At the same time, the individual horse legs lower and raise it. Transferring the horse from the deck of the Crockett to the water is the most critical and by all odds the trickiest operation in terms of crew teamwork. The crane operator must choose the one precisely right moment in the wave and swell cycle. It's then and only then that he must lift the horse and swing it around before the ship rolls again. During this short time, tugger lines at either end of the horse are slackened or tightened. Fine adjustments in the crane's boom position are made to align the horse with the laser beam on shore, marking the trench center line. Since the time that a diver may spend underwater must be minimized, he waits until the horse has almost touched bottom before going down to make the pipe joint. While the contractor's divers use conventional deep sea gear with full dress, the inspector divers use specially modified hard hat equipment with swim gear for greater mobility. Every joint is pressure tested to 120% of the design internal hydrostatic head. Underwater inspection of the Outfall construction was accomplished by Engineering Construction Services Incorporated of Seattle, Washington. Each time a joint is assembled, the pipe is securely bedded with gravel. To prevent the rock from spreading outside the trench, a tremie tube, much like a large shotgun barrel, is used to aim the flow to the bottom. The diver directs the placement of rock and tells the crew topside when to stop the flow. After the bedding is placed, a layer of larger rock up to 12 inches in size is laid to the crown of the pipe. Finally, armor stone up to 30 inches in size is piled 4 to 6 feet on top. This backfill design will withstand the hydraulic forces produced by a 50-year significant wave height of 46 feet. Like a giant spider, the Crockett repositions itself on its 6 mooring lines to lay the next pipe. The trestle extends a half mile through the rough surf zone too shallow for the pipe-laying vessel, the Davy Crockett. stabilize the excavation and protect the pipe from heavy wave action near shore, permanent sheet piling was driven to a depth 16 feet below the pipe invert elevation. The trestle pipe was laid by suspending it from cable slings. Joint assembly is difficult in the underwater surge. The solution to this problem was provided by a device which came to be known as the pony. Once in the water, the pony's outriggers extend to bear against the sheet piling on each side, stabilizing the pipe.
Okay, don't.
As pipe laying from the trestle nears the shore, the Davy Crockett, a converted World War II Liberty ship, lays the last few 48-inch diffuser pipes. The last structure to be placed at the 240-foot depth is the flat gate. As the pipeline reaches water depths beyond 200 feet, where diver time is severely limited, the contractor and inspector divers ride the horse to the bottom inside a steel chamber. This horseshoe bell provides normal atmospheric pressure and allows them to direct joint assembly without the risk of the bends or nitrogen narcosis.
How's it looking out there?
Okay so far.
How do we look, John? We gonna go right in there?
So you can come to Eva just a scope, just a second.
Inshore and a touch to Eva. In a touch on the pipe.
Hold on.
And again. Hold on.
To secure the flat gate to the last 48-inch pipe will require the use of a hard hat diver. 1 1/4-inch diameter bolts must be installed manually. And at this depth, it must be done in the shortest possible time to minimize the narcotic effect of the diver's breathing gas. After completing the connection of the flapgate, rock is again placed on the pipe and on the flapgate. This operation is directed by divers in the round diving bell. The flapgate marks the end of one phase of a vast program through which the city and county of Honolulu will maintain optimum water quality standards. As the crew takes that last ride aboard the tug, and the Crockett takes up her anchor lines and heads for home port, no visible reminder of more than a year of hard work remains. Victories like this one are largely unseen, but they go a long, long way toward preserving the quality of life in beautiful places. Places like Hawaii.